Tuesday. Everybody have a good day yesterday? I hope so. I think everybody was really tired by the end of the day yesterday, and it was only Monday. But we'll exercise, and it will be better as the week goes on, I'm sure. So really happy to see you all this morning. We have a lot of good stuff going on today. Just to share a little bit with you. So one of the things that I noticed and that I've had feedback from a number of people is the network is really good here. And so hopefully, has anybody had different experience in that? In any of the session rooms or the meeting rooms? And this is a tough crowd on networks, and if we can survive the network here, wow, that's pretty impressive. So great job by Ben and the staff here. So thanks very much for that. It makes all our lives so much easier and more productive during the week when we have a good network. The other thing is that the hacking rooms have just had record turnouts for the hacking rooms. It was really crowded yesterday, and Arwen worked tirelessly until about 2 a.m. last night to reconfigure the hacking rooms so that it should be a lot easier to work in there. There should be much more room for everybody today, so hopefully that really worked out. I know a lot of effort went into it, and we think it's fixed. The other thing that happened yesterday is that everybody rushed for lunch at 1. There were a lot of long lines and whatnot, so she's also reconfigured lunch today so that it starts at 12:30 to 2, so it gives everybody a little bit more time to get in there and have lunch, and hopefully that reduces the lines at the same time too. There isn't a meeting for all the assignees, so if you're a Linaro assignee in one of the working groups or one of the groups in Linaro or one of the segment groups, it's going to take place in Grand Peninsula Ballroom B, which is actually the ballroom directly across from here on this side. So please be there at 5:10. I think it'll be an interesting meeting. We won't keep everybody too long, but we have some good stuff to share, and we want feedback and that sort of thing. So we'll see you at 5:10 if you're an assignee, please. And there's also a soiree tonight, for steering committee members, and that's going to take place in Scalini, and it starts at 7:30. So if you have one of these little gold tags that actually says VIP, it really is an invitation to the steering committee soiree. So we hope to see you all there tonight at 7:30. Should have a good time. It always is. The other thing is, just by a show of hands, who's using the app on their mobile phone for the schedule? Right? Okay, so if somebody sitting next to you is raising hands and your hand's not raised, you should really download the app. It is really very good. It has the schedule, not just one for Linux. Okay. Feedback registered. But one of the functional improvements based on feedback that we had from everybody in Macau is now when you look at your schedule, so it shows the sessions and your meetings. Those used to be two different things, and now you should be able to see everything. The other thing is it has integration with Google Calendar now too, so that's much better as well. So you can even see the stuff that's going on outside of Connect. So it's worth getting if you can get at it. So today is Digital Home Group Tuesday, and we have a number of interesting events. I picked out a few here. First, we have our keynote from Ken Morse, who's the CTO of Connected Devices at Cisco. One of the interesting things, so this is digital home, right? And how do you know? In today's modern world, how do you know if someone's really the expert on something? It's not based on their university accreditations nowadays. It's not based on what they might say. But if you go to Google and type in digital home and that person's picture comes up, you know that that person's one of the experts in this area, right? And so that's what happened to me this morning. I was looking up Ken, and I went to Google, and in fact, his picture came up when I put in digital homes. So I thought that was pretty impressive. He's come all the way from IBC in the Netherlands to talk to everybody this morning. I think you'll find that very interesting. There's also 3 other sessions today, and the other thing that Mark Rogotsky wanted to make sure I shared with you is the fact that we have the box for the 4K demo. It has come in. You will see that on Friday. It's a great demo, and hopefully everybody get a chance to check that out. A few other items. So there is going to be a group photo tomorrow. We're not going to all hold hands like in the picture, but we will have a group photo. And it's going to be outside here where the desk is in this area out here. So put on your Sunday best for tomorrow for the photo that will live on. And the group photo is always fun, and it always survives for quite a lot longer than you think it would. And then on Wednesday night, tomorrow night, there's still the Jamboree, and there's a very few spots left. So if you're not signed up for the Jamboree yet and you'd like to come, it's going to be a good time. It takes place in the hotel, superheroes, rock bands, I mean, you know, it goes on and on. How can it be better than that? So that'll be a good time. So please give your name to one of the folks at the front desk if you'd like to get on the list. And then Thursday night, we're going to have our fabulous member services dinner at Sparky's Hot Rod Garage. This is just a little snapshot of one of the areas of Sparky's. We have a lot of interesting things planned for the day at Sparky's, and so that should be really good. So now I'd like to, if you could please join me in welcoming Ken Morse. Do that.
Okay, let's get this puppy going. Okay, good morning, everybody. First of all, fantastic turnout, excellent. Nothing worse than flying 12 hours from Amsterdam and having 12 people in front of you, so thank you. I appreciate it. So, I'm Ken Morse. I've been in the digital video space long enough, apparently, for my picture to turn up when you type it, for 32 years now. And I would tell you that it is an industry that is going through more disruption and uncertainty than I've ever seen in those 32 years. And so what I wanted to do in the time we've got this morning is take you through that a little bit, both in terms of how things are evolving in the move towards the cloud and what the implications for that are for devices in the home as we go forward. So enabling internet speed for service providers. So service providers, Cisco term that we use all the time, anybody who delivers managed services, so think Time Warner Cable, Comcast, AT&T, DirecTV, anybody like that. How do they get to internet speed? It's not something you normally associate with those service providers historically. A little slower, typically. In fact, in that space, the introduction of a new service typically took a committed business plan and at least 9 to 18 months to roll it out, develop it and roll it out. Which is totally unacceptable in the world that we live in now. So how do we give them that internet space? And I gave it the nice little subtitle, How I Learned to Be Open Sourced for Business, because open source really does drive a key piece of this. It is a tale of 6 numbers, and since I got off a plane, I'm going to keep wandering around because it's the only way I stay awake. The 6 numbers are 5 3/4, 22.8 petabytes, 7, $540 billion, $22 billion and change, and 50. So, 5 3/4. What is 5 3/4? Amazingly, 5 3 hours of TV are consumed per user per day. And the reality is, I know most of the people in this room probably are less than that, which means there's a lot of people outside of this room or a hell of a lot more than that. It's still up there, second only to sleep. And I think they do make the distinction between falling asleep whilst watching TV. 7. Lucky 7. Today, in a North American home, the average is 7 video-capable connected devices in a home. 7. And you can see greatly ahead of where it is in some other regions in the world. And also you can see how it's moving up to an average of over 9 just in the space of the next couple of years. Counts are growing everywhere. It's tablets and mobiles predominantly, but also it's smart connected TVs, it's game consoles, it's devices we haven't thought of yet. Give it to 2020, 50 billion connected objects. Used to say connected devices, but it's really objects now. It can be sensors, can be anything. There are going to be 50 billion devices connected to the internet. And by the end of this year, the number of mobile connected devices will exceed the number of people on the planet, which is quite an amazing stat. So there's a lot of people out there who have a ton of them in their cupboard. 22.8 petabytes. Big number, count the zeros. It is how much IP video traffic there is per month. Per month in the world. We do because of Cisco, we're sitting there in the middle of all these service providers' networks. We're able to put equipment in there that actually, see what's being utilized and how things are going. And we run a thing every year where we do all the statistics from that and do our projections for the next 10 years. Our projections have always been pretty accurate, but they've always been low. Things have always gone faster than we imagined. So when you see this VNI, Video Networking Index, have a look on the web. Tons of interesting stats for stuff around the world. I think the interesting one is that 2 years ago we created more data in 2012 than in the previous 5,000 years combined. It's just crazy. $540 billion. Show me the money. That's how much you and I spend on video every year. There's also an advertising piece that you can see in there. It is still going up, even in the markets that we have today. As you can see, in mature markets, a little less than in developing markets. And developing markets, especially when you look at things like Brazil, rest of LATAM, emerging markets in the Far East, huge growth. $22.4 billion. That is the opportunity in the space for a given year, for this current year coming up, which is made up of software to go into video devices, not just the devices, but also driving equipment in the cloud, network components for delivering video, and cloud infrastructure. And then dwarfing all of that is CPE. CPE stands for Consumer Premise Equipment. So that lovely little black box or silver box that's sitting in your home providing TV service that you probably hate some days and love the next, that is still a huge market. And one that, when we look at where things like Linaro is having an effect, becomes very, very key for us. One thing to note is this market is a market, as I said, that's in disruption. Our customers are getting out the checkbooks and writing very large checks. So when you look in Europe, you've got Vodafone, who sold off their stake in Verizon Wireless and got something like, I can't remember what it was, $45 billion in the bank, and they're off spending it. They're buying up a lot of the cable operators in Europe to become one of the biggest video providers out there alongside Liberty Media. You've got B-Sky-B, the incumbent satellite operator in the UK, Rupert Murdoch, just buying up Sky Italia and Sky Deutschland as well and bringing them together. You've got Comcast acquiring Time Warner that'll probably close in the first quarter of next year for $45 billion. You've got DirecTV and AT&T coming together for $50 billion. And then you've got Verizon buying all the assets that Intel developed for their on-queue OTT system here in the Valley recently for $200. As well as all of what's going on there with the operators, we've got a lot of over-the-top action going on, yeah? In terms of Google, with Google Fiber, they're rolling out pay TV. Apple is going crazy in terms of what they're building out there with CDN capacity in their data centers right now, which at some point will turn on probably a la carte video delivery beyond the pay-per-view, as it were, today. You've got Netflix, which pretty much on a peak night is close to about 55% of the traffic on the internet in the US. And only about 2 years ago, it was 26%. So it just keeps going. $8.99 is a very good price point. And also rolling out 4K services already. OTT has the phenomenal ability to stand up things quickly. And this is what service providers have to respond to. And then what Amazon's doing across their range of offerings as well. So I'm not going to walk through everything on here, but from where TV is going, the drivers for change are technology, business, consumer. We've talked about more devices and screens, getting better networks, better video quality. How do you manage the video quality end to end? A move from what was, I would call, very much dedicated hardware that delivered all of this in terms of capturing signals, encoding signals, processing them, stat-muxing them, delivering them over networks. We're moving to more general purpose computing, so standing up just regular compute and storage. We're getting elastic compute power to be able to dynamically scale on demand. We're using things like network function virtualization to move things into the right place in the network and leverage that in power, in parallel with the compute power from the elastic stuff. The home we'll touch on is getting a new focus, and open source we will go through as we go here. On the business side, people are trying to, who's got a DVR at home? Hands up. Fair number. So the big move afoot right now is how do you get that spinning hard drive out of the home and into the cloud? Something that you'd say, well, the OTT guys do it all the time. But they don't do it for, broadcast TV, for high-value content. And that's where these content rights are starting to evolve. We have all of the major service providers in the TV industry moving to what you hear cloud DVR. Yep, record everything in the cloud, stream it down to whatever device, give you the functionality that you need. But the thing that is gating it is clearly not technology, it is business rights. I will pick up on the consumer. What we care about is having our content wherever we want it, whenever we want it, whatever device. We want to minimize the pain of paying. When you look at the generations behind us, they actually take that to the extreme in that they don't want to pay. And security and protection, not only of personal data, but from the service provider's perspective, the content across the network. And give me the best experience possible, something that a service provider has, to use a technical term, sucked at in the past. The user experience on your traditional TV, probably not the greatest. Versus when you look at what OTT guys are rolling out next to it, that's what service providers have to aspire to and drive towards. So, oops. For them, they've got to lower their costs, they've got to move quicker and be able to put services out at internet speed, and they have to increase revenue. And also tying into increased revenue is reduce their operational things. They do that by lowering costs through putting virtualized solutions into the environment and matching that with the right balance of physical entities. They get agility through orchestration, being able to automate, bringing on new systems, spinning up new virtual machines for whatever functions that they need, being able to push things like user experience generation truly into the cloud so that the devices become pretty much dumb renderers, and then be able to drive applications rapidly out the door. Everyone is talking about the cloud. It doesn't matter who you are. The one I will focus up there is Comcast. So Comcast, one of those traditional companies that used to take 9 months, committed business cases to get anything out. If you're an Xfinity customer and you're using X1, X1 is their cloud-driven service that they started about 1.5 years ago. In the last year, they have made 1,200 updates to the user experience. Typically, they would do 2 code updates a year prior to that. So you can see where they're starting to embrace the kind of tools that you need to do these things. Cloud obviously drives, as I'm sure a lot of you are familiar with in here, faster time to market, gives us the ability to roll on resources as and when we need, have the scalability that we need to be able to stand up new virtualized instances whenever. We get portability of applications in terms of driving them out of the cloud versus having a device-centric nature of applications. Admittedly, mobile and tablet space today, we have a very device-centric view of that. But there's really 2 platforms to worry about. When you start trying to deliver video services across game consoles, smart TVs, with every CE vendor competing against each other with different operating environments, traditional managed CPE, phones, tablets, you need to have something back in the system, in the cloud, that will allow you to rationalize and actually get a return on investment in your development costs to hit all those devices. Big data and analytics, not necessarily something that's a benefit of the cloud, but when you think about the fact that all of the cloud components drive very, very good logging through the orchestration, drive open API sets to be able to communicate, it gives you a fantastic place for big data and analytics to kick in. What Comcast knows today about their network is phenomenal, for example. They know, what people are buying, how many clicks it's taking people to get to making purchases, and so they can minimize that. They keep spinning the user experience so it gets quicker for what people are really looking for to find it, which for them is very, very selfish. It just drives into higher purchase rates. That's all they care about. But they now have insight into the system to see how people use it and dynamically change it. So, I'm going to spin through this one very quickly. Data center. It's not just about data center. Data center is a good starting point where we can have our virtualized resource pools, but it really is about virtualizing network functions, being able to take things, have them in the data center, but also push them to other points along the network as well where we can maximize it. When you think of a CDN, for example, you've got a very distributed environment there. And especially as we move to elastic CDNs, it gets similarly the case. Being able to, on demand, drive our workload through this is key, and the orchestration for setting it up. So automation, virtualization, and orchestration, non-negotiable. You've got to simplify the operations. How you introduce new services is critical. And when you look on the right-hand side, actually being able to, for some of the first time, separate the software and the hardware, things that you think is very simple to do, but when you look at what people had built in this space, they were very, very tightly coupled. So starting to leverage environments like OpenStack to give that hardware-software separability and be able to have those run at very different rates in terms of innovation. When we look at what we're doing, we're building on OpenStack, building both our control planes and media planes on that. Videoscape is a term that you hear. It's our overarching umbrella for all of the video delivery infrastructure from a Cisco perspective. And then promoting, not surprisingly, a set of RESTful APIs out of that to enable very fast integration of services, rapid integration of third-party components, and bringing all of that together to ultimately deliver the apps and services that people care about. So there's just another slice of it, which is saying the fantastic thing with OpenStack and building our orchestration layer is on the left-hand side, you've got a set of services that are just always there for any function that you want to stand up. You're not sitting there worrying about how to do logging, how to do spin-up, how to do all those things. They're there as standard and available to all of the cloud components that you develop. Then promoting regular RESTful APIs from those. When I look at what's happening in the home is going through a lot of change. Some of it you may be oblivious to, some of it you're very, very aware of. When you look at digital video started, some would argue, with MPEG-1 back in the 92-ish. MPEG-2 came along as an encoding standard around 98 and halved the bandwidth for a given resolution and picture quality that was required to deliver it. Along came AVC H.264 in about 2006, which again, courtesy of Moore's law, halved the bandwidth one more time. And that's what really enabled the prevalent use of high-definition services. If H.264 hadn't come along, satellite providers could not offer HD service. Just the cost of the transponders to put out the 20 megabits a second that it was taking at that point in time for a high-definition signal was crazy. The interesting thing about encoding is you come up with a spec, all the decoders have to adhere to it, but the fun comes on the encoding side, because you've got a lovely toolbox. And it's a bit like, I normally use the analogy of game consoles. You know, PlayStation 3 came out. People were kind of blown away by some of the applications that they saw at launch, but then you looked a year forward, and as soon as developers understood what the capabilities are of that platform, it was another level again. And it's the same on the encoding side. So even though a standard comes out, you'll find that over the course of 4 years, as people understand that encoding toolbox, when we did high def in H.264, it was at the start 10 megabits a second. We're now doing it at 4 megabits a second. The spec hasn't changed. The decoders on the other end haven't changed. It's just your better knowledge about the encoding toolbox. And now we're going to high efficiency video coding. And would anyone like to guess what that's going to do to the bandwidth of the previous one? Halve it? Yeah, good. You're good. You're good. You're paying attention. So now we'll be able to deliver high definition in about 1.5 megabits a second. More importantly, deliver things like 4K and do the biggest 4K, which is 4K, what we call P60, so 60 frames a second, in around about 20 megabits per second. But it also enables things. I mean, it was interesting. If any of you, I'm sure you all scoured through the Apple announcement of the past week. And when you go and look at the specs online, it's hidden away in one little place that the A8 chip supports HEVC. It's hiding there in one little place. So you can imagine anything that's A8 powered going forward is going to be supporting HEVC, so the next Apple TV refresh, things like that. And so that helps in an Apple delivery model because it reduces, for those on lower bandwidth environments, the time to play, yeah, because you're sending half the bandwidth. So you're going to see HEVC be prevalent in OTT. You're absolutely going to see it prevalent in the mobile space. Combination of HEVC, LTE, put them together, you can deliver video services and deliver them cost effectively. We're moving to all IP. That all sounds like, but we're all IP already, aren't we? Not in the digital video delivery space, we're not. Stuff going up over satellites, stuff going over QAM-modulated hybrid fiber coax networks. People like AT&T, certainly all IP by the nature of it, but the majority of operators out there are not. And that IP migration has been interesting. It started kind of on the back end in terms of origination of signals and bringing them into where they're finally sent over the access network, which is typically not IP. And then when it gets into the home, we're now re-encapsulating everything in IP to deliver it to all those devices that you have in your pockets, sitting on the couch, whatever, that are IP as well. So the last link that's missing is that literally last mile infrastructure. And that's starting to move to all IP. And you'll see that and HEVC actually go in combination. Wi-Fi. Wi-Fi, you would say, prevalent everywhere. A service provider delivering high-quality, guaranteed service of video in the home over Wi-Fi only started 18 months ago. And you've probably seen all in the US, seen all the AT&T adverts. Their proposition for doing it, quite honestly, was one of when they came to install a system, they had to drill holes in your wall and run Cat5 between boxes to be able to deliver video, and an average install took 7 hours. And the 7 hours of an installer's time is very valuable. Wi-Fi had been progressing in terms of speed and reach and things, and we were able to do some interesting stuff on the antenna designs. And so 2 years ago of AT&T, we launched video to set-top boxes. And install times went from 7 hours to 1.5 hours, which AT&T liked. But then the advertising for it started. And all of a sudden, you didn't know you had a need to move your TV wherever you wanted in your house, on your porch, wherever kind of thing. But suddenly you had a need for that. AT&T said, you have a need for that. And that's how they positioned it. And it went through the roof. 5 million of the boxes were shipped in literally under 1.5 years. Gigasphere, you can thank some marketing executive for coming up with Gigasphere. It's actually DOCSIS 3.1. We were talking about that move to all IP in the delivery. DOCSIS is what drives your cable modems today, high-speed infrastructure. Today, an operator can push services getting close to up to 1 gigabit over that link. DOCSIS 3.1 is coming, next generation, and going to drive higher and higher performance over that link. In-home gateway architectures. So before, video used to come out of the back end, delivered over the satellite, wireline cable into a house, and you had to have a set-top box behind everything to be able to view TV. What's changed is you can now deliver, obviously, to mobile, to tablets, to other devices in the home. And the reality is those little set-top boxes, or what should be little set-top boxes on the right of that bottom left picture, need to start looking like every other device that you have in your home. Because up until now, they've been proprietary. Or as I used to, for 20 years, present them, very nearly open standard. And as we know, very nearly is not good enough. And to get the rate of innovation in terms of services, you've got to make one of those puppies look like any other device you have. You've got to have a kick-ass HTML5 environment on it. You've got to have, you know, a huge vendor base there being able to bring things to market. You've got to have SOC vendors who are bringing standardized reference implementations to the table to make it happen. And that's where things that we'll touch on, like RDK, obviously Android, starting to play in the set-top space as well, become key. And also the gateway device on the left-hand side, which is probably the single least sexy device that you have in your house. It just sits there and blinks a lot. Is actually going to be probably the single most critical device that you will have in your home. Because the one on the right of it, at some point in the future, may not exist, because you'll just be receiving video on any old device. But the one on the left is not going away. It's only getting more important. We've talked about consolidation, Internet of Things. I'll tell you, when you've had too many beers in Amsterdam and you try and say Internet of Things, you become Irish, because it was Internet of Things all of a sudden. I'm not sure where that was coming from, but Internet of Things is huge. We're all probably fed up of every company has to talk about it now. But just seeing what is going to happen there, and then the role of that always-on device sitting in the home that is bridging to all of those sensors that you have and ensuring quality of service, quality of experience between those becomes critical. And there's tons of pressure in the marketplace. So there is, I'd like to say there's a prize. Joe might give someone a prize. There's something on this chart twice, so off you go. But there's tons of things going in this space. There's more buzzwords, more acronyms than you can imagine. And HEVC, congratulations. I didn't realize I'd put it on there twice when I first did it, but I've been driving a lot of HEVC strategy recently, so it was probably subliminal that it came out that way. But tons of things going on in this space. As I said, we're seeing the move of functionality that used to live on the right-hand side in the device start to move into the cloud, or in some cases into network components. So, you know, there's just a sliver of functionality that you think of in a set-top box, a digital device. How do you move that across? Cloud DVR, prime example that I was giving you there. Even things like device management, as we start to do things where we can actually virtualize the CPE and actually have layer 2, layer 3 all the way up into the network can be looking directly in, especially as we go to IPv6. And so it's not necessarily even about having a device to actually monitor locally. The network, as long as you've got a connection there, can do that as well for you. So a lot of things that are happening here. The message that we give internally is that third message. Set-top boxes, CPE development in general. Having spent a lot of time in the space, I know that the badge of honor for most of the engineers and developers was they measured what they did by how much code they wrote. And now we tell them we measure you by how little you write. It's about how you leverage, how you use open source, how you use other distributions, and the value that you bring is bringing those together in new and innovative ways and increasing the quality of the product and increasing the agility and the time to market of the product. We have got our customers over the hump of the concept that we are going to update software on them on a daily basis. People view digital video, television, as a lifeline service. Yeah? When it goes out during the Super Bowl or goes out during the Ashes, that's a big deal. And so it is a big hump to get people over to be able to start doing the kind of service agility that we're talking about now. So just a real simple example here. So DVR. So DVR today, you're recording locally in the device. Inside the device, you've got a lump of logic there that's scheduling. It's managing all the different tuners, working out what conflicts you may have. You know, working out, oh, this is a live event. Do you want to add 30 minutes, an hour to it? So all that resource management, conflict resolution. And then there's a recording functionality function as well that's sitting there and saying, right, top of the hour, it must be Saturday, it must be Doctor Who, let's start recording that. And all of that hiding in, you know, some middleware of some description with an EPG providing the user experience on top of it. And really all it needs from the network is give me the metadata. Tell me what's going on, what's happening when, give me the jacket art, all of those good things. You then take the middle step, which is you move the scheduling, the resource management, conflict management, all out into the cloud. You get some great benefits from that as well. All those applications where on your phone you want to schedule something to record, that's great. It hasn't got to go all the way and touch that box in a home. It just talks to the service in the cloud, which is how many of them operate today. But you're still left with this recorder sitting there managing local hard drive recording in the home. And then you move fully to the cloud. And at that point, you're recording everything in the cloud. You're leveraging cloud DVR so you can deliver to all devices efficiently. You can encode in different formats. You can optimize for delivery like HEVC to reduce the bandwidth for devices that support it. And then you'll notice on the EPG user experience, we've added there the term just renderer. Because the logic of the EPG, the flow of it, all of that is actually now done in the cloud. And all you're pushing down is templates as and where. Literally, and it's a scary proposition, but literally the majority of key presses are going all the way back up to the cloud. And that's where we managed to get now in terms of the scalability of these systems. Comcast X1 runs this way today with 4 million subscribers sitting on the back of it. So these things are being solved and addressed as we speak. A lot of people are still doing the intermediate and actually having all of the code sitting there, and some of these guides and everything that you see on TV now, typically when we go to browser vendors and say, well, here's our application, they go, I have never seen so much JavaScript in my life in a single application. The applications to drive these are huge when you think about everything that has to happen in that set-top environment. So being able to take the complexity of that and imagine the staff years of testing to validate that in a given device and then another given device and move that out to the cloud is critical. So, nerve center of the connected home. That is the non-sexy box, the gateway device. It has a few functions. It has to terminate the existing network. And so that might be, you know, DOCSIS, it might be DSL, it might be satellite, it could be a whole bunch of things. And be able to be basically that network termination device that enables on the left-hand side of it the service provider and on the right-hand side of it the home. It potentially can do video termination as well. Some don't, some do. And in video termination, that's being able to say, okay, anything that I've got, the encryption schemes, all of that that's on that video that's coming into the home, I'm going to stop it right there and re-encapsulate everything in IP. And now I'm standards-based popping out the other side of this, so any other device can connect. We're even doing things where literally you take a constant bitrate stream in on the left, and what you're putting out on the right-hand side is obviously a single, but an ABR profile, so that HLS devices can just access that. Why would you do that rather than going over the top and having a unicast IP connection? Bandwidth. You know, leveraging IP multicast. When you look at these video signals, you know, it's a gigabit of video that you're delivering into the home for all the channels that are there today for broadcast. And so being able to leverage the efficiencies over the network and then turn it into unicast once you get into the home for the devices that can only understand that's key. Storage and caching. CDNs are going all the way to this device now. We actually have storage in this device, so this is node 0 of your CDN, and it allows you to pre-position content, be able to, over time, even use that CDN for peering within a residential area as well. So you have to look at how you balance network delivery, network design, and workload for all of this. Home network connectivity, how this device is now the thing that is responsible for bringing your entire home network together. So that's Wi-Fi, that's MoCA in a lot of cases, multimedia over coax that can deliver 900 megabits, guaranteed quality of service over the existing coax that's sitting in your home. It can be other technologies as well. Wi-Fi is the fastest evolving one here. We're now putting literally just coming up to 4x4 AC into these devices. Comcast is just announcing their latest one that delivers a guaranteed 700 megabits per second inside the home for their Xfinity homes that we've worked on them with. Home network and device management. The biggest set of calls that AT&T ever received as a company was on Christmas Day 2010. Because everybody unwrapped their iPad and wanted to know why it didn't work. And so they got a lot of calls. When we look at the connected home, you can't not be proactive in terms of managing the network that's inside that home. This always-on device knows everything about the devices that are in there, what devices are in there, what the access links are like, what's the quality, what's the dropout spin. And can do lots of things like proactive management. You know, someone comes home with a company-configured static IP address laptop, plugs it in, it automatically gives them a temporary IP address. Little things like that that would have otherwise resolved in a phone call. A phone call is $10 to $15 of lost revenue for an operator. So whatever you can do in this device, critical. Software environment. I did want to talk a little bit about software environment. Sorry about the contrast, I should have chose black. Even inside these devices, we are leveraging open source software to the hilt. The gateway stack that we built there is one that we've subsequently open sourced the rest of it. It's built on dbus, a bunch of other things hiding in there. And so you can find it on the Cisco GitHub right now. And as part of the RDK initiative, Comcast and RDK LLC have actually taken that and used that to form the basis of the RDK for broadband devices. So some of you may be familiar with RDK and set-top boxes. There's going to be the equivalent RDK for broadband inside this device. And that's something that if you go out to the Cisco GitHub, you can go and have some fun looking at that right now. And for those of you who may know Sri Kote, the chief architect at Comcast, who I think his shades are always affixed right about there. I've never seen them not on him. That's him committing the code when we did it. Other things that get into the software environments, I'll touch on when we get into the set-top side. Enhanced services, so this is everything from service provider Wi-Fi. You're probably noticing now inside your home, there's actually a couple of SSIDs. There's the SSID that you get, and then there's a public SSID. And part of that is to drive service provider Wi-Fi. So as well as service providers putting up all those hotspots all over town, your gateway inside your home is also got a dedicated piece of bandwidth, not the bandwidth you're paying for, a dedicated piece of bandwidth that is available as a hotspot as well. So this is another way to get blanket Wi-Fi coverage of services across the country. Connected life is everything from security to automation to all manner of things that we're seeing coming at us. You've seen in the US, AT&T deploy digital life, home security, home automation, $29 a month. You've seen Comcast deploy similar services as well. It goes pretty much everywhere. It gets into health, it gets into fitness. But what you need, again, is as all these sensors start appearing in your home, whether it's talking to your intelligent garage door opener or whatever, you need a device that is aggregating and communicating with all those sensors. So do you have yet another hub in the home, or do you leverage one that's already there? And so a lot of the early systems have been absolutely a separate hub, but going forward, the kind of devices that we ship here, just so you get an understanding of what we're talking about on these. This guy has a Puma 6 MG sitting inside it, which is an Atom, 3,500 DMIPS, and the generations that are just shipping now have a gig of RAM inside them. So these are meaningful devices to be able to do something on. Running Linux, and actually the Puma 6 is a dual core in the sense of, not the typical sense, but there's an Atom in there and there's an ARM sitting in there as well that we use for a lot of the functionality. Virtual CPE. So we talked about how things are moving out of the home functions back into the cloud. And the gateway itself provides a lot of that capability as we go. So as I was saying, as you flatten with IPv6 and things like that, that home network and device management could conceptually be done further back in the network as it looks into a very flat network to see what's going on inside your home. That little set-top box. So a lot of these things are similar in terms of what's happening, but there's some differences as well. Form factor. So the hockey puck is normally what people like to refer to. When we did our first ever two-way, it sounds so antiquated now, two-way IP-based digital set-top box in 1993 with Time Warner in Orlando. It's called the Full Service Network Trial, so 21 years ago. And the box was yay wide, yay high, yay deep, and you could cook eggs on top of it. And if you ever see a picture of one, for Bay Area aficionados, you'll recognize an indie workstation, because we did it with SGI. So there's an indie workstation that formed the basis of it, and then we put a bunch of cards into that indie workstation to handle all the vagaries of digital video delivery, QAM demodulation, all the fun stuff. And amazingly, the chip that we built to handle all of that extra stuff was ARM-based. in 1993. So a nice little linkage there. That box cost $7,000 a piece. And when it went out the door, it went to 4,000 homes in Orlando. And the intent from Time Warner's, and it had a 3D user interface on it. It was wow for the time. And the intent from their perspective was to understand how people will use a service like this. What applications? How much will they use it? What will they pay for things? It was really a marketing trial. But they were smart in that the functionality that they put into it, they said, by the time we actually get to productize it, we'll have all that functionality, but in a smaller device. And it'll cost $400. And in 1997, 4 years later, we turned on the real commercial system with Time Warner, and the box was $400. But it had 3D, had more horsepower than an Indie Workstation, more memory than an Indie Workstation, and that was just the nature of it. So we got some very good data there. Where am I going with this? Form factor continues to go down and down. What people normally ask me is, so isn't it just a Chromecast stick? And the answer is maybe at some point. The difference between a service provider and you and me going and buying something at Best Buy is, for the service provider, they don't want to take that $15 call. They're not going to take it, or try to avoid it anyway. And they want to have a guaranteed quality of experience. The wireless that is sitting inside a Chromecast, just because of the power budget that you have today, is, you know, you've got a choice of how much CPU do I put in there, how much graphics, how much Wi-Fi. And the reality is you can have 2 good ones out of the 3. You can't have all 3 good. And so Wi-Fi with the 1x1 is where it took the hit. And you and I will move access points around. We'll do whatever to get that Chromecast to work. But that's not what a service provider is in the business of doing. And so that's not something that works viable for those service provider guys today. So what you're seeing instead is form factor reducing and reducing, where we're getting to the point of set-top boxes that are a little bit bigger than an HDMI stick, but are perfect for a piece of Velcro behind that flat screen TV. And then moving to not IR, but RF for CE and other remote control interfaces, and since they're Wi-Fi enabled through other devices as well, all those kind of things come to the table. On the SoC side, on the system on a chip side, it's getting real interesting. As I say, when we did that first commercial deployment in '97, it had a stonking 54 MIPS in the box. It was a microspark, and it had, when we started, the design was a meg of ROM and a meg of RAM and a meg of flash. No, a meg of ROM and a meg of RAM, that was it. By the time we got to deploying it, it was a meg of flash and a meg of RAM. All of the smarts we did into the operating system to do dynamic patching of ROMs and all of that good stuff was wasted, but it was a good design. When I look at what we deploy today, we have chips in front of us, courtesy of mobility of tablet and phone, that, you know, you guys probably take for granted. You know, we're up to quad cores, 20,000 DMIPS, all manner of things. It took the digital video industry a good 14 years before we ever saw Moore's law kick in. We didn't have 1,000 DMIPS in one of these puppies until about 4 years ago. Yeah, and so now we just see it going crazy. And this is one of the nice things, is when you look at the SoC ecosystem, a set-top is a tablet, but with an HDMI output. And invariably now you're getting HDMI outputs on tablets too. So a lot of the same chips become applicable. Now there's still a lot of smarts and special stuff about traditional digital video delivery that you need in there. So it's the Broadcoms, it's the STs, it's the Entropics of the world. But you see new people coming into play in these devices, especially as these are all IP devices with the passage of time. So the Marvells, the Qualcomms, people like that start to be very relevant. The one thing that I will say is absolutely happening is the rationalization of what CPU to see in these devices. It's ARM. It's over. We're done. Yeah. There's no microsparks, no MIPS. There was some Atoms and x86s until Intel decided to step away from that side of the business. and they're focusing more on the gateway side of things. But from a video decode, they're ARMs, which is good because we've now got a ton of energy efficiency regulations sitting on the industry, and ARM can solve that. Storage and caching I've talked about, home networking connectivity I've talked about. The one thing I did want to talk about on this one is the software environment a little bit. So RDK and the role of Linaro as well inside that. And you could put Android up here as well. We built Android set-tops, or should I say we developed and prototyped them probably 2-3 years ago. And our customers was always a little wary about Google and what's the right business arrangement and things like that. The industry, led by Comcast, went off and put a lot of activity into the reference design kit, RDK. And this is an area that we've spent a lot of time over the last 3 years on. So it's everything from supporting different SOCs, from the usual suppliers, plus some other ones. When we did our own chips, we used to come up with very funky names, as you can see down there. In terms of integrating and deploying across ranges of set-tops, you're seeing traditional set-tops, you're seeing hybrid ones that can take data off the satellite or off the coax, as well as have an IP connection to your broadband, so you can blend high-quality premium video and IP-delivered video to have very, very compelling on-demand experiences. HEVC, wireless, things like that. I'll bump through those. What we're doing with Linaro, when we were contacted and made aware of the activities that were going on, it was something we absolutely wanted to be involved in. For us, open source is becoming a way of life. Yeah? At Cisco, at the biggest Cisco, I think Cisco is the number 21 contributor to the Linux kernel because of, it used to make sense when I said because of iOS, which is the Cisco operating system, whose naming we licensed to Apple. We actually had iPhone as well, if you can believe that. We actually had licensed the name iPhone to Apple for them. We are very good corporate citizens. We could have got a lot of money for that, but we didn't. But I think we did then go and take every other I name we could think of, just to be careful. So the kind of things that are happening here, and you're going to hear more about this during the course of today, are things we really care about. How do we leverage HTML environments in here? How do we get the right performance? How do we enable proper end-to-end encrypted streams through this environment? So leveraging things like encrypted media extensions into this. These are all critical for us. How do we get, some of the challenges left with RDK is the SOC vendors are bringing different open source revisions and packages to the table. There's not standardization there. Every SOC vendor has their own build environment. So when you're a vendor on the other side of it, you're the one who has to scale to support all of that. With the activities that we're doing here in conjunction with Linaro, we're going to flatten that. And that's going to help us as a vendor, and it's going to help the community and RDK as a whole to really take on new capabilities. CAS and DRM integrations, RDK comes with just a couple of things outside of the box, so being able to integrate those, and as we go forward with things like EME, we'll be able to do that much more readily. And then a lot of contributions that we've done as well into RDK itself, and there's a bunch of video-specific stuff hiding up there, but even things like IP multicast, IPv6, RDK didn't support IPv6. To give you an example, we had a customer in Eastern Europe. They said, I want an IPv6 end-to-end video delivery system. We said, fabulous, we'd love to do you one. When do you want it? 50 days. Oh, crap. And we leverage an RDK-based platform, put IPv6 in it, put that in with the cloud environment, and boom, we were done in 49 days. So these things can be very, very rapid to come to market. User experience is critical. The good news is when you look at the graphics engines that are starting to appear in these devices now, you look at the CPU to go with that to drive the browser, you can do some very, very compelling things on these platforms finally. And from a video format point of view, it's the HEVC that I talked about earlier. So that's the next evolution. And also being able to do some smart things like take even traditional HD and drive it with 4K upscaling. If you look at the stats, everyone's, the one thing I will say about HEVC and 4K versus HD, And none of us talk about 3D anymore. It's just a bad experience. We don't talk about the 3D introduction. But HD took quite a while to get embraced. And it took quite a while for the device costs to come down, especially the TVs. You can go on Amazon today and for $700 get a 55-inch 4K TV set. Now, I wouldn't advise you to buy the $700 one. That's the first thing I'd say. But when you look at an LG, a Samsung, and a Sony at 55 inches, all below $1,800, that's when you know that the technology is already there. And in fact, it takes, at that screen size, those CE manufacturers, it costs them an incremental $200 to do a 4K versus a 1080. So basically, in a year, you won't have a choice. Anything you buy over 55 inches will be 4K, because they're not going to have multiple SKUs. They've got fixed shelf space. You will all be buying 4K TVs. Whether or not you're feeding it with 4K, another issue. Yeah, that all comes to where service providers are going. But you can watch House of Cards with your Netflix subscription on that 4K TV right now, which is, again, showing the power of OTT and how you can stand up things very rapidly. I've just got a couple more things to touch on. Security in general is a huge thing. One of the things I was giving a talk on at IBC in Amsterdam was on Internet of Things and all of these connected devices. And security there, as you can imagine, is huge. Because when you look at it's all great that we can, aggregate between all these different services. Nest promotes an API, and Nike this and that, and the home security, and boom, boom, boom. But it's like, think of the scenarios for those getting hacked. They are life-threatening scenarios. And so security across end-to-end systems becomes key. Security in terms of any device that tries to connect into that infrastructure is key. We are going to find ourselves with a combination of root hardware security, so the trust zone kind of implementations are really, really key to this connected life, Internet of Things environment as we go forward. It's a very scary proposition, but it is one that I think the industry will be able to move through. I talked earlier about the cloud rendering. This is something that we did 5 years ago. As you can see, it was 4K before there was 4K, so I think actually it was more like 6K. We had 6 HD screens up there. And everything that we rendered here was totally out of the cloud. It was all HTML5, all the logic pushed to the cloud, and just some very kick-ass at the time x86 servers sitting behind all of this and driving this experience. But again, it showed how you could greatly simplify what has to happen in the home element and actually move that functionality back through the cloud. Connected life I touched on. This just gives you a view of how we certainly see it coming out and what some of the key pieces are. That home gateway is a critical control point. How we enable rapid integrations, the use of open source to be able to do that. One area that I have not yet seen, so for any of the ARM folks in the room, there's an opportunity there to get ARMs into those devices. They are not ARM-based today. I'm not seeing any of the vendors really going that path yet, but I think they will, especially as we start to see the volume and the recognition of there's one of those in every home pick up. Security I've touched on. The whole intercloud is going to be critical in terms of how you aggregate and interface between all these different services. And then what's always going to be interesting is what drives it into the marketplace. Is it actually consumers paying for things? Is it advertising? Is it a combination of those services? And then building out the foundation that you need to be able to support all of this here. User identity and credentials is going to be key. We see everything that's going on with the hacking that's going on out there right now. As I say, becomes more and more important as we go forward. So, in summary, the video industry is very robust. Those big numbers at the beginning, it continues to be a growing industry. The joke we've used over the 3 decades I've been involved is every time there's an economic downturn, you can rely on the purchases of 6-pack beer and TV subscriptions. Those are 2 things you can rely on. If you're in Canada, you can rely that when winter comes, there will be a lot of video on demand purchases. There's some basic rules that we've seen time and time again. It is going through some of the largest changes in its history, both from a business priorities, the technologies that we've been talking about, and the architecture. Again, to a lot of you, who are more familiar with, the web-centric driven world, kicking and screaming is this industry as it comes into that kind of thing. But it's at a very opportune time to be able to do that. Move to all IP transitions, non-negotiable, just like the cloud. Open source and distributions is just non-negotiable, yeah? It's interesting. Inside Cisco, we have an open source initiative, as you can imagine, across the company to ensure that we adhere to all our obligations. And I got acquired by Cisco. I was with Scientific Atlanta. We got acquired by Cisco, 7 years ago. And at the time, they actually did an audit internally, because it's like, how many licenses are being used? And the answer came back, 67. And the best one, and some of you in here are probably familiar with it, is the beer license. And it was this individual, and he written his own license, and it basically said, if you see me in the street, buy me a beer. And that was his license. And believe it or not, Cisco Legal was trying to work out whether delivering a crate of beer constituted a fully paid up license. And you may be wondering, those smart people, there was another number, which was 50. And that's just my little joke. I just turned 50. So hopefully this was useful to give you some insight. I know there's some more materials coming from other people during the day that'll dive into this a little bit more. But digital video, the connected home, huge, robust, growing industries, and ones that quite honestly need your help. So we welcome the help of every one of you in moving the industry forward. Thank you very much.
Thanks a lot, Ken. That was a great presentation, great energy for a Tuesday morning to get the LHG day off on a good start. And we've got a few minutes here. If there's any questions, I'm sure Ken would be happy to entertain them. Yes?
Oh. Net neutrality, it's a wonderful thing. I love the John Oliver segment, what can I say? And if you haven't seen the John Oliver segment, go and look it up. Yeah, as a vendor, you know what's coming. As a vendor, we have to be very careful, yeah? And so I think what our customers are looking at is, they have to spend a ton of money on the infrastructure. And you can argue, lucky you. But to stay competitive, that is forever moving. And so you saw, like with DOCSIS 3.1 as an example kind of thing. These things just keep moving. And I think there just has to be a balance in some way, and there's many ways that can be achieved, not just even the net neutrality discussion, yeah, for them to cover the costs of the infrastructure that they put in place. I think what you're going to see is, especially as now those infrastructures are flattening, especially for, like, say, their video delivery. We've already gone through broadband and voice, quote, on the same network. Now their managed video delivery is on the same network. And so their opportunity to actually recoup their investment cost is much, much better, yeah. But I think you're always going to see the positioning that we're seeing. I wish I had a silver bullet answer for you, but I haven't. Yeah.
Part of the market opportunity that you identified there was various forms of advertising.
Mm-hmm.
And yet, one of the key appeals of fast-growing services like Netflix, they're ad-free.
Yep.
Can you comment on that, obviously?
Yeah, well, I think, yeah, the question was, talked about advertising being a big, you saw it there, there's probably a third of the money kind of thing in terms of the growth. And a lot of the rising services like Netflix and the like are popular because of the lack of advertising. Discuss. So what I'd say is, people in general don't like stuff that's forced on them. And they really hate stuff that annoys them and is not relevant to them. If you can make advertising relevant, you can change that. And this is the thing that is starting to come into play as we get, especially with the all IP delivery environments. If it's something that is valuable, if it's something where if I opt in, I get some other benefit from it kind of thing, these are the things that people are starting to play with. As well as also having tiers that say, and for an extra $3 a month, I'll never show you any advertising. Yeah, so to pay to not get it, as it were. So I think you're going to see a range of offerings evolve in that space. What I would tell you is, certainly in our research, the biggest thing that people like about Netflix is A, the price, and then B, the content choices that they have. Even though it might not be the greatest, it's stuff that keeps them busy and keeps them occupied, yeah, and certainly has the right set of binge TV show watching capabilities. I think you've got to look at what an overall aggregated services looks like, and it's interesting, some of our customers are actually embracing Netflix in their offering, mostly in Europe right now, but we may see it happen in the US, where Netflix is just another service that's there. When you search for a piece of content, if it's available on their service, it's great. If it's not, and it's on Netflix, they show Netflix kind of thing, and provide you with a unified environment. I think you're going to see more and more of that as you go forward, and more of an evolution of the ad models as they start to be able to do more and more what I would call beneficial targeted ad. Plus, it's on all the advertisers to make funny advertisements, in my mind, you know. I love UK advertisements. They have a much better sense about them. Yeah?
You talked a little bit about Internet of Things, home gateways, right?
Yeah.
The proliferation of devices increases in the home, and the growing need for home gateways. How do you view the current state of protocols and standards in that?
Okay, so the question was around Internet of Things and relation with home gateways and more devices coming, and what is the take on the standards for interconnectivity and things. As ever, you know, the long-running joke is standards are a wonderful thing. There's so many to choose from. And the same is true right now in the connected life space. You know, whether it's Zigbee, whether it's Z-Wave, is it low power Bluetooth, is it Wi-Fi? The answer is yes. It's all of those. Which again becomes the power of having a central gateway that today can bridge across all of those, because you know you've got markets out there that have driven phenomenally low-cost sensors, yeah, using particular radio techniques. And everyone go, well, why isn't it Wi-Fi? Well, if Wi-Fi was, you know, a penny, yeah, we'd do it. So I think it's important that the gateway can bridge between those, and then we'll see a natural evolution with Moore's law and everything else, where those will ripple down a few more. You know, if I was a betting man long term, you know, it's going to be whatever is beyond low power Bluetooth and Wi-Fi, yeah. But that's out there, yeah. It's 5 years away at least, kind of thing. So I think right now you have to embrace them. And then the important thing is where these services all come together is not in the home, it's in the cloud. Yes, it's all about those API that are promoted kind of thing. The interoperability can be generated there. And the funny thing is anybody can be an aggregator in this world, yeah, because all the APIs are published to a degree. And so it's about how you bring the user experience to the table that brings those diverse things together.
Wrap it up here. Dr. Ken Morse, thank you very much. We really appreciate this energetic discussion. And move on to the next one.
Thanks.
Just you can sort of read it, and lots of wonderful things happen in Linaro. People work really hard, and it's good to recognise where people kind of go above and beyond. I don't recommend working till midnight every day for everyone, but this came out of a bit of a conversation with Arm and Roger and various folks. It would be great if, you know, we could do a release of the LSK and stuff on Juno. And a lot of people worked incredibly hard across a couple of companies And it's not just engineering, it's obviously project management, product management, you know, and I just stood by and made tea, frankly. But all of these people are involved, and I'm going to read out their names. I'm going to make them stand up. They do have an award. I'm not going to give it here. It's out the front. But it's a really, really great project. Everyone worked incredibly hard, and the results are great because now we've got Juno with Android on it, starting to be used across Linaro, and you know, folks are downloading it. It's really good. So, Ryan, where's Ryan? Oh, well, he's hard at work somewhere, as someone said. Tixie, they're usually together, so if Ryan's not here, I can't see why Tixie would be. No, okay. Kazim? Oh, there he is at the back. Go on, Kazim. Amit, Milosh, Vishal, Mr. P, Mr. Piggott. He's probably having a late breakfast, knowing Dave. Fathy. Thank you. Jacob, Mark Brown, Cantor, where's Cantor? Yay, at the back, well done. Cohen and Mark Horvath. Where's Mark? There he is, the chap at the front. From ARM, we've got Liviu. I'm sorry if I pronounced that badly, but where's Liviu? Andy Pickard, David Ambrose, Basil, John Niven. Where's Roger? He's in there somewhere. He's probably in a meeting. Steve Bannister. Oh, right. So, yeah, they're all having a meeting probably about this. Anyway, thank you very much. It was an outstanding effort. Collect your award outside. So have a good day. Go and enjoy yourself.